The goal of SSDAN has always been to democratize access to social science data, especially for use in education. So a lot of the programs that we put on try to provide access to census data, American Community Survey data, and other resources that are useful for use in education, but as well as the broader public. This webinar has been provided by with support from NICHD. Some of the information is down below. If you've been with us throughout this month, this will be our 4th webinar. The recordings of each, if you were unable to attend any of the previous webinars or you'd like to see what we covered in the previous webinars, are available on the page that's mentioned below. Now, a little bit about Dr. Kyle Walker. Dr. Walker is an associate professor of geography at Texas Christian University and director of the Center for Urban Studies. He is an R developer, developing multiple R packages, including some that we will see today. He has taught a wide variety of courses in geography, particularly human geography. He has also taught data access and visualization using R, Python, and GIS. And he has also developed a virtual course called Analyzing US Census Data in R. With that, I will hand things off to our presenter, Kyle Walker.
All right, well, thank you so much, JP, for the kind introduction. And thank you to all of you for coming out today. Thanks certainly to those of you who have attended the previous 2 webinars and are still coming out to spend some additional time learning about some of the features available in tidycensus and other packages. And thanks to those of you who are coming out for the first time, who may not have come out for the first 2 webinars. And so I've tried to structure today as best as possible to be relatively self-contained, but there is going to be some information in today's webinar that builds upon information that was learned in the previous 2. What that means is if anything feels like it's going over your head a little bit, or it's not covered in as much detail as you might like, the video recordings of the previous 2 webinars are available, and you would be able to review and pick up a little we're leaving off here. But I'll try to make this about as self-contained as possible. A few things, housekeeping details that we'll want to cover before getting started here for those of you who like to follow along. I'm going to go ahead and share my screen and show you some of those resources that I'm talking about. All right. So what we're going to be going over today is a variety of functions and to work with US Census data, but also to work with international census data, which you'll be learning about in the 3rd hour of this webinar. And so there's a couple of resources that JP had mentioned that might be helpful to you as you follow along today, if you would like to follow along interactively. One is the link to the slide deck. So the slide deck that I'm using here is hosted on my personal website, and the link to the slides was provided by JP in that email that he sent out. So you can follow directly along on the slides on your own computer if you'd like. The other is the link to the GitHub repository. So I am sharing all of the code that I'm using for this workshop and for this webinar in the GitHub repository. And if you did miss previous webinars with me earlier this month, you can go back and review the code that we use for those webinars. So today's code, if you're familiar with GitHub, comfortable with a Git-based workflow, is going to be found in this Microdata folder. So if you're comfortable with Git and working with R, you can clone the repository to your computer using the instructions that I've provided. That will pull down the entire repository and you can open up the folder and get to work. If you're a little bit less comfortable with that, you can click the code button and download the zip file that will download all the materials for all of the workshops to your computer, which you can unzip and then get to work on your own machine. Now, those workflows are going to be probably what you want to do if you're already an R user, if you're comfortable using R and you have it already installed on your machine. In the event that you do not have R installed on your machine, you'll notice here there is a link to an RStudio Cloud project, which is a hosted version of RStudio, a popular integrated development environment for R, which I'll be using today. And if you click that link, you can sign up. If you have a GitHub account, you can use that. Or if you just have a Google account, you can use your Google account. You can sign up for a free account and run many of the examples in this workshop. There will be some limitations that I'll make you aware of as we walk through this. If you do use RStudio Cloud, you're going to see an example that looks something like this, where I provide you with some instructions. RStudio Cloud, if you're using the free version, does have a couple limitations that I just want to make you aware of. You'll be able to do most everything, but not everything will work perfectly. RStudio Cloud has been having a little trouble installing some of the development versions of packages. And what that basically means is there's a couple new features that I'm going to be highlighting today that you may not be able to run in RStudio Cloud. The other issue with RStudio Cloud, if you're using a free account, is that you only get 1 GB of memory. And given that we're working in some cases with larger data files today, that won't be sufficient to run every single example in the workshop in the same R session. And so you can monitor your RAM up here. And if you're getting up into the red zone and that gauge is going all the way to the right, it means you're running out of memory. In the event that that happens, click the session drop-down menu. And what I would recommend doing is either restarting R, or if it's lagging, you can terminate R entirely. This is something that you may need to do if you want to try to run everything, especially some of the more computationally intensive processes that we're going to be going through today. RStudio Cloud is wonderful because it gets you up and running with the free tier, but they do also have paid tiers for those of you who are interested in this platform who might need a little bit more computing power and computing performance. So hopefully this is enough to really get everybody up and running. And one example that some of you who are new to R might consider doing is trying out some of the code, at least as much as you can do in RStudio Cloud, and then when appropriate, taking it over to your own version of R that you install on your own computer that's going to have a little bit more memory to work with, and then continuing to build your skills from there. All right, so with that in mind, let's go ahead and dive right in. So today's workshop is titled ACS Microdata and International Census Data. Appreciate the introduction from JP. Again, I'm an associate professor of geography at TCU. I've been working there for the better part of the last decade, and been doing research primarily in population geography. That's my area of interest. More recently, focusing on software tools for open data science in population geography. That's really where my research trajectory has gone in recent years. Additionally, I work broadly as a spatial data science consultant, working with organizations of lots of different sizes. And if any of you are interested or intrigued by what's going on here, please feel free to reach out to me. I would love to discuss what you're working on. As JP mentioned, where a lot of my energies have been focused in recent years is in developing our packages. We're going to be working with tidycensus today, which is an R package that I co-author with Matt Herman to access data from some of the most popular data resources provided by the US Census Bureau. A couple other packages that I've discussed in previous workshops include the Tigris package, which is used to acquire and use US Census Bureau shapefiles in R, and the Mapbox API package, which is the subject of a workshop I gave that was recorded at the University of Pennsylvania last fall that allows you to interact with Mapbox web services in R. The content that I'll be covering today is really the final third, or much of the final third, of my forthcoming book, Analyzing the US Census with R. There's going to be more content in the book than I shared today, but this is definitely a preview of the book's content. So, as mentioned, this is the third and final workshop in my 3-workshop series that I've been giving this March for the University of Michigan and SSDan. Today's focus is on microdata, which I'll explain more in just a moment, and international census data, so non-US census data. The 2 other workshops that I gave are an excellent primer on some of the other capabilities of the tidycensus package and how to work broadly with census data in R. On March 4th, we focused on an introduction to analyzing and obtaining US Census data with tidycensus. And on March 11th, so a couple weeks ago, the focus was on spatial data, spatial analysis, and mapping. So if you're interested in reviewing those materials, if you weren't able to attend those workshops, they are up on YouTube and you can go take a look. So also, as JP mentioned, we're organizing today's content into 3 sections. This will give us a chance to take a break, stretch our legs a little bit in between sessions, but also organize the content, ask some questions, and do some exercises. In the first hour today, we're going to focus on using American Community Survey microdata with tidycensus. This is brand new functionality in tidycensus that is new to the package in the last year and is something that I, in particular, am quite excited about. In hour 2, we're going to delve in a little bit deeper and explore some advanced examples, focusing on how to analyze microdata appropriately, use survey weights, how to model microdata, how to map and visualize microdata. So whereas hour 1 is focused more on really understanding what microdata are and what you can do with them, hour 2 is going to get into really some applied examples of how you might actually do some analytics and do some research with those resources. Then hour 3 is kind of a bonus hour because this was not originally advertised as part of the workshop, but certainly we focused in this workshop series on United States Census data. But many of you are interested in or coming from a non-US context, and there are a lot of great resources for working with non-US census data. And so we're going to do a kind of a survey, an overview of some of those resources to highlight some of those R packages and maybe get you started working with some of those non-US resources as well. So a couple things thinking ahead to hour 3. I try to make everything as replicable and self-contained as possible in these workshops. That becomes a little bit more difficult when we're going outside of the tidycensus ecosystem and looking at other R packages for other countries. And so if you want to run every single example in this workshop today, you will need to get API keys. This isn't fully necessary, as I would say the last hour is more for a little bit of show and tell. This is what you can do. Go try that after the fact. But if you would like, something you can do right now or in the breaks is go grab an API key for Canada and for Mexico. The Canada API key, you'll establish an account with the Census Mapper service. For Mexico, you'll grab an API token from their National Statistical Agency, INEGI. If it doesn't come through the first time, maybe try again. It sometimes takes me a couple of tries to get it. But that's where you'll want to go to get API keys to run those examples. All right, so let's move now into part 1, using ACS microdata with tidycensus. So a little bit of an overview and a refresher even for those of you who have attended or maybe haven't attended the previous workshops this month. We're going to be focusing today on tidycensus, which is an R package that I originally authored back in 2017 to try to ease the process of retrieving and analyzing data from the United States Census Bureau. It's a package that I now co-author with Matt Herman, and he's contributed a lot of the new functionality to the package in the last year or 2. But the package, when I originally authored it, was designed to, ultimately be a tool that I could use to try to make my work a little bit easier, and then hopefully make others' work easier as well. So what it does is it communicates with several popular APIs. So those are going to be kind of places where you can go and fetch data programmatically from the US Census Bureau. It pulls that data into R and formats it in tidyverse friendly format, or tidy format, which means format that is a format that's ready to go for analysis with tidyverse tools like dplyr and tidyr, or with visualization tools like ggplot2. Additionally, the package communicates with my other popular R package, Tigris, to pre-join geographic data. And so if this is something outside of this context that interests you, something tidycensus can do is answer questions like, well, I want to make a map really quickly of median household income by county in Texas. And instead of having to go to different data sources, pull down the data, format it, merge it together, tidycensus can do all of that for you by default. And if you're coming to this workshop for the first time, something that you might consider doing is working through some of the examples in the GitHub repository. So if you look at the census data in our folder and you go into the code subfolder, you'll find an R script called part 1 code. That's for the first workshop, and you can go through and try all that out. For the second workshop, which focuses on spatial data and mapping, find the code subfolder in the spatial analysis folder, and you'll see a bunch of information and a bunch of code that you can go ahead and run as well. And so for those of you who may even have attended the previous workshops, that's a nice frame of reference. I'll keep that up so that you can go and use that as a learning resource. Additionally, for those of you who are joining for the first time and are using RStudio Cloud, if you click the Files tab in RStudio, you'll see that those scripts are also located in your RStudio Cloud account. And so all of that is available. If you missed a couple of things and you want to learn about those topics, you can go back and refresh your memory. So tidycensus has grown a fair amount since I first started working on it in 2017. My original goal was to make it easier for me specifically to use American Community Survey data to satisfy kind of common workflows that I would do in my work, my research and professional activities. And so eventually that included decennial census data, and I've added support over the years for some other data resources. tidycensus doesn't access every census data resource. You'll want Hanarek's Census API package, which is a great package for that purpose. Her package covers all of the APIs. tidycensus focuses on a select few. But we've been adding support for a few more APIs as we go. And what I'm going to be presenting about today is something I'm very excited about: new functionality to retrieve microdata, so individual level American Community Survey microdata from the Census API. Coming soon, and this is not highlighted today, but my collaborator Matt Herman has been hard at work on integrating the Migration Flows API into tidycensus. So for those of you who are enterprising, you might check out some of the activity in the GitHub repository and see what's been going on there. But there's some exciting new content coming to tidycensus in the next month or so. So especially if you're new today, some of this vocabulary might be a little bit unfamiliar. What is microdata? What is the ACS? What are we talking about here? So the US Census Bureau does they do a lot of different surveys, but the two arguably most popular data resources they have are the decennial census. So the complete enumeration of the US population that takes place every 10 years. We're eagerly awaiting the new data from the 2020 census coming out. But every year, the Census Bureau conducts an annual survey of American households called the American Community Survey, or the ACS. And the ACS asks more detailed questions than the decennial census does. So you can get information in the ACS about income and education and topics that you're not asked in the very sort of short decennial census form. And so the American Community Survey, and this is something I covered extensively in the first workshop, is a survey. As such, it's a sampling of the US population, and its estimates are in turn subject to margins of error. However, what's interesting about the American Community Survey is you can get access to ACS data in multiple formats. Many of you are probably familiar with working with aggregated ACS data, so pre-tabulated data at a variety of different census geographies. For example, what is the median age of counties in Utah, or how many people who have a doctoral degree by census tract, live in different census tracts in my county, that sort of thing. The public use microdata series gives you access to ACS data as well, but in a different format as individual level records rather than data that are aggregated to geographic units. And so it allows for much more detailed cross-tabulations than are available in the regular American Community Survey data that you may work with at aggregate levels. Now, granted, the public use microdata series covers a fraction of individuals in the ACS, about 1% of the US population in the 1 year. PUMS, which is an acronym I'll use here to refer to the public use microdata series. You can get it as a 1-year data set or a 5-year data set, which covers about 5% of the US population. We'll talk in hour 2 about how to use sampling weights to get representative estimates of the population at large. So the US Census Bureau makes this microdata information available from a variety of sources. You can get it in bulk from the US Census Bureau's FTP server, and we can open up that link just to take a look, and you'll see stuff like this, where you can pull down files, really CSV files that are zipped up by state. And some of those files end up getting fairly large. If we go down and find Texas here, got 71 megabytes zipped, you can pull down for the entire US population if you want to. You can also grab data using the brand new MDAT tool from data.census.gov. And so following this link, we can take a quick look at the MDAT tool, and this is what it looks like. It's still in beta, but it allows you to interactively query PUMS data. And so we're looking here at the 5-year estimates, so the 2015 to 2019 American Community Survey, and you can browse through all these different indicators, select variables, select geographies if you want to, by state or by public use microdata area, which I'll discuss more in just a little bit, and then ultimately download an extract of data for the variables and the geographies that you want. So there are a couple different ways in which you can go ahead and pull down that information. For those of you who have worked with microdata before, however, you may have used these census data resources, but at least in the worlds, where I, learned how to use these resources, coming up through social science graduate programs, most people that I came across who are researchers were interacting with microdata through IPUMS, the Integrated Public Use Microdata Series, which is a project out of the university's Minnesota Population Center, where I actually did some doctoral work as a graduate student at Minnesota. And IPUMS is a phenomenal project. And if you've worked with IPUMS data before, you're familiar with how amazing of a project it is. It is an effort to provide harmonized, so kind of reconciled data over time at the microdata level, going all the way back, as you can see, to 1850. And so, for censuses that have been unlocked, so to speak, you can even get 100% microdata, so full data sets from the US Census. It's a fantastic resource for historical and contemporary social science research. And they include a variety of other data sets as well, from the current population survey, international data, which I'll talk about toward the end of the workshop, and some other data resources such as NHGIS, geographic data. But IPUMS is a wonderful resource. I use it heavily in my own work. And what you'll do, if you'll establish an account there, you will use their data browser and data cart to download a custom data extract and then get to work and analyze. IPUMS R is an R package that helps you work with IPUMS microdata in R for those of you who are R users, and works really well for that purpose. What I'm going to be talking about today, however, is an alternative approach to obtaining census microdata, which for many cases, you might still want to go to IPUMS. In many cases, you will still want to go to IPUMS, I should say, but in some cases, you might consider taking a look at tidycensus to pull down your data in an automated sense. Last year, when poking around on the US Census Bureau Slack channel, which if you're into census data, the US Census Bureau has a public Slack channel that you can go ahead and sign up for. That's where you can get direct touch with census staff and get questions answered about their data resources if you like. I encourage you to check it out. But I noticed a couple posts about this, and so I went over and took a look at the MDAT tool. And when you go to download the data, I noticed here that you can see an API GET query. So basically a URL, much like the types of URLs that tidycensus consumes from the aggregate American Community Survey or decennial census, and processes and then gives back as an R object. But a way to programmatically access microdata. This is not something that had existed anywhere else before, and it's not something that was documented. And so I started chatting with my collaborator, Matt Herman, about this, and originally wrote just kind of a skeleton to try to pull this data down and process it and really think about what the best structure was for it. And we ended up getting it working. It wasn't working 100% well at first. There were a couple wrinkles because this is an undocumented API that we had to figure out. We had to put in some requests to Census Bureau staff to clean a couple things up. But now the implementation is highly functional, largely thanks to Matt Herman's work to really create an interface that smooths out and facilitates the process for working with microdata. You know, for me as a social science researcher and analyst, this was one of the more exciting data developments I've seen in the last several years, the ability to programmatically access US Census Bureau microdata and resolve a variety of issues, having to kind of deal maybe with large data files and deal with some data download times and really kind of speed up and streamline the process. And I want to show you how all that works today. So let's go ahead and take a look at how we can start using this information that the Census Bureau is making available to us using tidycensus. So if you're brand new to tidycensus and you didn't attend the previous two workshops, not to worry. If you're using RStudio Cloud, you already have the packages that you need installed. If you're not using RStudio Cloud, I'm going to jump over to R here and we can go ahead and get started and make that a little bit bigger. What you'll want to do is install the packages as listed up here. What I have here is all of the R packages that we're going to be using today. You can install them using the install.packages command. You'll note that I'm installing here the development version of tidycensus. If you can't install packages from GitHub, say you're on a work computer where GitHub's blocked by a firewall, this is something that can and does happen. You can install tidycensus the regular way or use the published CRAN version of tidycensus to get to work. Much of this will work, not all of it will. Only a couple examples won't though, so you should be in fairly good shape. Once you've done that, tidycensus requires a census API key to work. You can access census data resources without an API key, but tidycensus doesn't allow that to happen in its own setup, just because you'll be heavily rate limited. And to really use the full power of the census data resources provided by the API, you should be using the API key. So if you're just getting set up and you're new to tidycensus, once you have your packages installed, you're going to want to load the package with library tidycensus, and then use the census API key function, replacing your key goes here with your own API key to set that as an environment variable that can be used throughout your R session. If you use the argument install equals true, which I recommend unless you're working on a shared computer, that will write out your API key to your .renviron file and allow you to use it in future sessions without having to call the census API key function. I do have a sample API key provided for our Studio Cloud users. Just run the code that's provided in our Studio Cloud to get going. Once you have that authenticated, you can get started using microdata in tidycensus. And the way that you access individual level microdata in tidycensus is with the get_pums function. And get_pums works for those of you who have used tidycensus before in a familiar way. You need to specify variables. It could be a single variable as a character string or a vector of variables enclosed in the C function like you see here. It's recommended that you use a state as well. You can use familiar state codes to do that. You can specify state equals all. This takes a really long time. If you need data for the entire United States, the 1-year ACS is doable. The 5-year ACS for the whole United States is about 15 million records. It is somewhat unstable over the API, and for those use cases, go to IPUMS for that, or do a bulk download from the census website. But 1-year ACS is doable for the entire United States, but just prepare to be patient. So the function defaults to the 5-year American Community Survey with the argument survey equals ACS 5, but you can grab 1-year ACS data if you want. This will be, you'll get fewer observations, but it'll be faster to download with the argument survey equals ACS 1. And generously, the Census Bureau has provided data all the way back to 2006. You can get data from the API back to 2004. We don't support in tidycensus right now, 2004 and 2005. Those data are formatted a little differently. So we began support for the 1-year ACS in get_pums in 2006. And for the 5-year ACS, we start support for the 2005 to 2009 period. And so looking at the code, this is all the code you need to get started pulling down microdata from the ACS. We're going to use Wyoming as an example here because it is the smallest state in the US. And so download times will be relatively quick for pulling data down for Wyoming. So I'm specifying here inside the get_pums function a vector of variables. I'm going to grab sex. I'm going to grab the code here for age, which is age P, and I'm going to grab the code here for educational attainment, which is school, SCHL. I specify state equals Wyoming. If I want the 1-year ACS, I specify survey equals ACS 1. And the year defaults to 2019, but I'll be explicit about that here. So jumping back to R, let's go ahead and try that out. So we're going to run the code here. Let's see what we get back. Takes just a moment to download our data. And this is what we have. We have, it looks like around 6,000 observations with a variety of columns. And I'll explain what all these columns mean in just a minute. We see a serial number, we see SP order, a couple of GTP variables, which I'll explain in a moment. And then we have some of the variables that we requested. We have age. So the age of the individual here is located in this age column. We have school, and we have a numeric code that represents some level of education, and then we have a code representing sex. So this is what microdata look like. We have 6,000 records that are representative of, as you can see here, if you know Wyoming's population, this is about 1% of Wyoming's population. And so we have information here that, when analyzed appropriately, can be used to try to think about and make some inferences about characteristics of the population in the state. This probably doesn't all make perfect sense yet, however. And so we're going to go through a variety of different functions and sort of characteristics of the data to help this make a little bit more sense. So a few things about what you see when you use functionality in getPums. getPums will always return a series of technical variables by default. So you as the user don't need to request them specifically. If you want to do any analysis of this information, you need to have these technical variables. And so that's why we return them by default. The serial no column, the serial number, is a serial number that uniquely identifies households in the samples. So the American Community Survey uses a complex sample design in which they sample within sort of what are called PUMAs, or public use microdata areas, which I'll explain a little bit more in a moment. And then they sample households within them. And so you'll get a household serial number. And then the SP order column is the order of the person in the household. So if you combine that with the serial number, that'll uniquely identify a person. WGTP is the household weight. So what that means is the number of households that each household is representative of. And then the PWGTP column is the person weight. So that's the number of people that the individual is representative of. And so if you go back to R and take a look at some of this information, you'll notice these first few entries have a household weight of 0. That's because you'll see this GQ. Those are group quarters observations, which are not included in general household tabulations. So those are people living in places like dormitories or in jails, or elderly care facilities that aren't considered households in the same way that others are in the census. But all of these people do have person weights. And so this first person here, you can see the person weight of 47. You can think of, okay, this person and its characteristics are representative of about 47 other people. And so you can go down the line. There are going to be some people that are relatively oversampled, and they might have a lower person weight, and some people that are undersampled. You see this person has a person weight of 75, and in turn are weighted a little bit higher. So PUMS data, as mentioned, they're a sample of the US population. And so you need to weight your data appropriately if you want to actually draw, inferences about the population at large. And so what we can do is use base R functionality and also some tidyverse functionality to analyze our data in a little bit more robust way. Let's say we wanted to ask, well, given our data set, how many people in Wyoming are age 50 about? Or what is, the overall population of Wyoming? And so what the code here shows is we can use the filter command from dplyr in the tidyverse to create a new data set in which it's only people that are age 50. And if we sum across that person weight column, summing across that column should get us a total population. And so running this code, we can take a quick look. And we see here that summing over the entire person weight column for Wyoming gives us a value that is the recorded population of Wyoming from the 2019 ACS. So if you went and used get ACS to get aggregate data for Wyoming, the actual estimate for Wyoming is exactly this number, 578,759. Where microdata get handy is getting more granular estimates than are available in the regular ACS. So if you look at population by age and sex, which is the very first table in the ACS, it doesn't break out into individual bands of age. It'll collapse some ages together. And so if we want a single age and say, well, how many people are age 50 in Wyoming, we can sum across our filtered data set and we can get this value back. So a couple other ways to try to work with PUMS data, work with PUMS variables, and learn a little bit more about how this works. You may have been thinking, okay, um, this sounds great, but how do I know what variables are available and how do I know what all this stuff means? Well, you have Matt Herman, my collaborator, to thank for this. He created a data set called PUMS variables, which loads in tidycensus. It's your one-stop shop to browse and find variables that you need and what they mean in your microdata. So PUMS variables is a long-form data set. All we have to do is run the command view PUMS variables to take a look at it. And I'm going to go ahead and take a look at it here and pull it up in our studio. These are all your variables in the PUMS. Now, we only have data dictionaries for 2017, 2018, and 2019 because they're not provided in easily parsable format before then, but you can still go through here and take a look at all of these variables. And this is a long form data set as mentioned, where you'll see here that in the var code column, it'll give you a variable code. But you'll notice that say ST for state is repeated. That's because each row represents a code and value combination. So if you were to fetch state level data, you'll get a code back. Say if it says 25, that code means Massachusetts. And so we can go through and browse. Let's say we're interested in Hispanic origin. I'm going to search for HISP. And we notice here we have a variable called HISP, recoded detailed Hispanic origin. We can scroll over and take a look at the different values. So value 1, 01 is not Spanish, Hispanic, or Latino. Value 02 is Mexican, value 03 is Puerto Rican, and so on and so forth. This is a fantastic data dictionary that you can use to go through and figure out not only what information you want to pull down from the Microdata API, but also what the different codes mean. Beyond that, however, if you don't want to go through and actually scribble down what all the codes mean, some functionality that we built into tidycensus is the recode equals true argument. What this will do is append a series of columns to the data set that are recoded and can be used for, I think, more comprehensible analysis. And this was a contribution from Matt and from tidycensus contributor Stephanie Zimmer, who have allowed these labels to be ordered in the correct order so you can get straight away to analyzing your data. And I want to show you briefly how this works. So if I change my call to include recode equals true and I run it, you'll notice I can see that I get a label for my categorical variables. Age is numeric, that's not categorical. We know 37 means 37 years old. But I'm going to go ahead here and I'm going to pull up my recoded Wyoming data set in the viewer, and you can see that whereas 16 in the school column, okay, that's great, but what does that mean? Does that mean 16 years of school? No, it's just a code that is representative of a particular value. We see here that that value means regular high school diploma. And here we have a sex label as well. We see 2 means female and 1 means male. But this can really be helpful when you're analyzing your data and starting to understand what's going on inside of your acquired PUMS data set. A couple other features that I want to show you before we move into a break. One issue that arises, and I've gotten this feedback a little bit, is when you're working with PUMS data sets, especially from the 5-year ACS, they can get really, really big, which means data download times can be slow. I want to show you a couple ways that you can speed this up. If you have the CRAN version, so the published version of tidycensus installed, this won't work yet. This is part of the development version of tidycensus that's hosted on GitHub. So you won't be able to run this in our Studio Cloud. If you can't run it on your own machines, it's coming soon to the published version. So just stay tuned. This is a relatively new feature where we're using functionality in the API to allow you to filter down your data. For example, let's say I only wanted to get values 16 through 20 for the school variable and a value of 2 for the sex variable to analyze a specific subset of people in the data set. I can do that using a named list passed to this parameter variables underscore filter. So you're functionally saying here, give me back only those rows where sex equals 2 and school is between 16 and 20. If I run that through, and again, this won't work unless you have the development version installed, but I can run that information through. And you'll notice here that in this, all of the values for sex are 2, and all the values for school are between 16 and 20. If you are looking to analyze a subset of information, this can really speed up your download times. The last piece that I want to cover before we go into our break is thinking about geography in microdata and how that's handled. Geography in microdata is a little bit different than what we're accustomed to when we're working with, say, aggregate ACS data. One amazing thing about the American Community Survey is that we can get detailed aggregate demographic information all the way down to the census block group, which is analogous to, in some cases, a part of a neighborhood. Individual level data don't have that same geographic granularity, and for good reason. The census is very, very protective of privacy and confidentiality. Some of you who are seasoned census data analysts may have been following debates around differential privacy in the 2020 census data release, in which in some cases data values will be swapped to try to preserve privacy and make it difficult to sort of retrace. Those sorts of methods are already used to a degree in the microdata releases. What you're looking at is a data set in which care is taken such that you cannot directly identify any individual in the data set. So if you're looking at a particular row and you're wondering, well, I wonder who that person is, that's not exactly what microdata means. It's designed to be representative of US and regional populations such that you can do coherent analysis. It's certainly not designed for you to be able to understand the identity of any individual. And indeed, you can't do that using this information. They include some kind of swapping of records in the data set to preserve overall characteristics, but also preserve confidentiality as best as possible. And so as part of that effort to preserve confidentiality, you can't get microdata all the way down to, say, the census tract or the census block group level. The most granular geography at which you can retrieve and identify records in the PUMs is the public use microdata area, or PUMA. And so what is a PUMA exactly? It's the smallest available geography, as I mentioned, at which the records are identifiable. And they're redrawn with each decennial US Census. Typically, they're home to between 100,000 and 200,000 people. By the end, say by 2019, using 2010 PUMAs, you'll have some PUMAs that have more people than that in areas that are fast growing. And what this means is that, say, in a large city like New York City, for example, PUMAs are drawn roughly to be representative of community areas or community districts in New York, which are sort of salient neighborhood areas. And so if you're analyzing, say, Los Angeles or New York or Chicago, say a large city, you can actually identify coherent subsections of cities and do some geographical analysis in that capacity. When you get out to more suburban, lower density, or even rural areas, you're going to sometimes have to put together multiple counties to reach that 100,000 person threshold. And so PUMAs, like you can see here in Wyoming, might represent a collection of counties. So Wyoming has 5 PUMAs, and you can get the geography for PUMAs if you want to from the Tigris package. For those of you who didn't attend the previous workshops, We covered the Tigris package extensively in hour 1 of workshop 2. It is my R package that allows you to pull down US Census Bureau shapefiles, so geographic data for all of the geographies at which the census tabulates data. And the pumas function in Tigris, you can see the code here, will pull down pumas by state if requested. And so you can visualize that information. We see how that plays out here in Wyoming. The puma variable in the PUMS data set allows you to identify those individual records by puma and then do some geographical analysis as best as you can when appropriate. And so if you say wanted to look at age by puma, I could pull down age data and I could grab the puma variable. We can take a look very quickly at how that works by running that code here in R. And here I now have information I'm grabbing from the 5-year ACS in this particular case, and you'll notice that I have information by puma. And so I could think in general terms about where regionally in Wyoming these different people live. If requested, we also include an argument called puma. If you say only want to get data for a specific puma or a subset of pumas. And so pumas are identified by puma code. In this particular case, puma 500, the code is 00500. You can take a look at that. And let's say I only want to grab data for that specific puma. I can specify, give me age data, but only for that puma. And if I want to run that through, you'll notice that I only get data back for that specific area. So if you're analyzing information for a specific area, or you could even do a vector of areas as well, that can be really handy to, parse down those, or at least kind of take down those data download times. So the variables filter command, the variables filter argument, the puma argument, these are all things that could have been done on the R side. Conceivably, you could pull in the entire data set and then filter or subset your data after the fact. But what this does is it restricts the data that's coming out of the API from the census website, and in turn cuts down on your data download times. So this is a handy tool in that capacity. If you're trying to figure out what puma codes to look at, there's a variety of things that you can do. The thing that I usually do, which is maybe a little bit more advanced, is exactly what we covered in hour 3 of the second workshop. I will use spatial overlay to pull out puma codes if requested. Another thing that you can do, and this is using some information that we went over in the previous workshop as well, is grab the appropriate data set using the Tigris package and then use the map view function to interactively browse your data. And so if I were interested specifically in analyzing Laramie and Cheyenne, I could click and I could see, okay, that's Puma 00300. That's the one that I want to take a look at. Or if I'm interested in taking a look at this area here, up by Teton County, that's Puma, the Puma code is here, 00100. I could pass that to the Puma parameter as an argument and get back data appropriately. So having these interactive tools at your disposal to go back and forth can be handy. All right, that wraps up part 1. So let's break for around 10 minutes. We'll come back maybe around 3:05, maybe a little bit after 3:05. And so take some time to stretch out and do a couple exercises if you want to. A couple recommended exercises. Try requesting some PUMS data for yourselves, but for a state other than Wyoming. Just be warned that, especially if you want 5-year data, if you're looking at California or Texas or Florida, download times can be a little bit slower. But for small states, it'll usually be pretty quick with a high-speed internet connection. Additionally, try using that PUMS variables data set. Use the view command in RStudio to pull it up, browse it through, and then try creating a custom query where you pull in some different data. We were looking at age, sex, and education in this particular example. Try pulling in some other data and use that recode argument as well to help you understand what you're getting back. So let's come back in around 10 minutes or so. We'll have some time for Q&A and get into the second section, which is really getting into some robust analyses with the data that we've acquired.
All right, great, Kyle. All right, everyone will meet back at 3:07. Hey, everybody, we have about 1 to 2 minutes before the break ends. 1 to 2 minutes. Okay, everyone, we're going to get started. We have a few questions for Kyle that have come in the first hour. Plenty of questions. We'll try to get to as many as we can. But the first question that I have is, does Get PUMS access the PUMS household data or just the person data?
So it's a good question. It accesses the person data. But if you want to analyze households, you'll notice that we do provide the household weights and we provide the person weights. So the way that you would want to go about analyzing households, two things. If we pull up our PUMS variables, so I'm going to view PUMS variables again here. You'll notice that I can filter down this data set by a variety of different columns. So if I click filter here, let's say I want to do 5-year ACS for 2019. And if I scroll down, you'll notice in this level column, we separate out different variables by housing and person. And so that'll tell you which variables are appropriate for household level and person level analysis. If you want to do household level analysis, and come to think of it, this might be a good option to put in there. You'll notice when you take a look at our data here. So see what's on the screen highlighted here. Each household has a serial number. There are 3 people within this household in the data set. You can see there's one age 38, one age 36, and one age 5. So that is likely a couple and their child. And you'll notice the SP order column 1, 2, 3. So generally speaking, when demographically we're talking about a household head, if you will, that person will be considered number 1. And so if you want to do household level analysis, you would want to subset your data down for only those records that have an SP order of 1. And that'll allow you to compare across households, and then you could use the household weight accordingly. So it's an interesting comment. It makes me think about maybe putting in a feature where you could just pull down household level records automatically. I think that's something to consider, but that's the workflow that you would use for the time being.
Great. So we have a question a little bit more about the data beyond the data themselves. So is the PUMS data a subset of ACS data, or is it the whole set of ACS data that was sampled? Yeah. So is it a subset of all the respondents, or are they all of the respondents to the American Community Survey in that year?
Again, that's a great question. Just kind of going back here. So the PUMS data is a subset of the American Community Survey. It is not all of the respondents to the American Community Survey. So the American Community Survey covers about 3 million households annually. So it covers about 10 million people annually. The ACS covers, which is about 3%, give or take, of the U.S. population. The one-year PUMS only covers about 1% of the U.S. population. So you're getting about a third of the responses from the ACS. For those of you who are academic researchers, some of you might be familiar with the federal statistical research data centers that are across the country. I believe there's one up at the University of Michigan. I work at one over in Dallas. And you can get access to a larger sample from the American Community Survey in microdata form there, with the significant caveat that it took me about 2 years to get access and approval to do research there. It takes a little time, but you know, that's an option for those of you who are academic researchers and are looking for a larger sample. The public data, we're only talking roughly about a third of the ACS. So it's interesting, and you can play around with this. Generally speaking, for larger geographies, your estimates, your tabulated estimates from the ACS PUMS will match very closely with the aggregate data you'll get back that the Census Bureau publishes. But when you start getting more granular for smaller populations, you're going to notice some variance.
Thank you. And then one last question before we let you get to the second hour. So is there an option for running git pums just to get, say, the first 10,000 rows back from through the API, similar to what users of SAS might know, obs equals, say, 10,000, to just grab the first 10,000 observations?
Not at this time. You would need to pull down your data and then use data filtering tools, say in dplyr in the tidyverse to do that sort of thing. Okay. So conceivably, you could do something like, you know, using base R notation. I'm gonna, let's say I have this information. What's my largest data set? So I have Wyoming, age by Puma. That's the 5-year ACS microdata sample for Wyoming. So it has about a little under 30,000 records. If I wanted the first 1,000, I could do something like using base R notation and grab the first 1,000 rows, something like that. Give me back 1 to 1,000. But we don't have an option in Git Pums at the moment to only pull down, say, the first, you know, N records from the API.
But if you were interested in just grabbing a selection of the results, you could use some of the strategies that you brought up earlier, such as using the filter. Is that right?
Exactly. You could use the filter command and filter for the first N rows if you want to, or you could subset your data using bracketed subsetting notation from base R, like I've done here.
Great. All right. Well, we'll turn things over to you for the next hour. Thanks, Kyle.
Excellent. All right, so moving into part 2, and I noticed there were a few questions in the Q&A that will be answered in part 2. So, so stay tuned for that. Now that we've learned how to acquire PUMS data in R, how do we go about analyzing it and modeling it appropriately? And this is something that is important to consider in working with PUMS data. It's not just your normal data set where you open up a CSV and start doing crosstabs. That's not how the data are structured. It's a complex survey sample that's weighted. And so if you were just to tabulate your data without using the weights columns, you would get incorrect estimates. You get incorrect results. Beyond that, um, these are drawn from, again, using a complex survey sampling design, and they're designed to be representative of the US population, but because they're a sample, any estimates that you tabulate will be subject to some degree of error. And this is why, as I discussed heavily in the first workshop, but just to review here, tidycensus, when grabbing aggregate ACS data, always returns the margin of error. This is a really important consideration. This isn't based on a complete enumeration of the US population. It's based on a sample used to make inferences about the general population, which in turn means that there's error. There's error that you need to account for around these estimates. And when you do highly detailed cross-tabulations, which is one of the principal benefits of working with PUMS data, your errors might be pretty big. So we're going to talk a little bit about how to generate those errors and how to analyze them and incorporate them into your analysis. And so, but these are things that you really do need to think about. The PUMS data are great, but if you don't use them the right way, you're going to get incorrect information back. You can't just fire them up and start saying, okay, here's my data set. There's 75 people who are men in this Puma between age 50 and 55. That's not what it means. It's a weighted sample, and you need to incorporate those weights. And so I'll show you some strategies for handling that. So tidyverse tools and some extensions to the tidyverse are pretty fantastic for handling some of these considerations. So I'm going to pull down some data for a state that's a little bit larger than Wyoming. So we're going to go Mississippi. Mississippi's got a little under 3 million people, whereas Wyoming has under 600,000. And so we're dealing with a larger sample size here. The data download time will be a little bit slower, just as a heads up, because we're pulling down from the 5-year ACS. And so I'm going to go ahead and pull that data down and get that download started. So we're grabbing data from the 5-year ACS for Mississippi, and got a little download tracker there. It'll take a little bit longer than it did for Wyoming because we're pulling down around 5 times as much data. All right, so we've pulled in data using the variables that we were using in the previous example for Mississippi. So just as a refresher, we're getting PUMS data where the variables that we're getting back include Puma, sex, age, and educational attainment. We specified recode equals true, so we can get those informative labels. And we're doing it for Mississippi from the 5-year ACS with an end year of 2019. So the 2015 to 2019 sample. We can inspect our data real quick and just see what's going on. Looks like this data set is bigger. It has nearly 150,000 observations in it, and then has information that's attached to that. So we have many more Pumas to deal with than we were dealing with in Wyoming, which means we can maybe do a little bit of geographical analysis. We'll take a look at that in just a moment, and quite a bit more information to draw from. So the first thing that I wanted to show is really using dplyr tools in a basic way to do weighted tabulations. And let's say we wanted to tabulate in Mississippi basically how many people of each sex are at each age in our data set. And so we can use the count function in the tidyverse to do that. And so in this case, what the count function does And just as a refresher for those of you a little bit less familiar with the tidyverse, we use this pipe operator to do data wrangling in the tidyverse, which reads as then. It basically passes the result of the previous line to the next line. So it says, generate a new data set called MS age sex. That's the result of taking the MS PUMS data set that we downloaded, then applying the count function, which basically just tabulates information with the optional argument here, WT, which is the weight column. So it says how many observations is each row supposed to represent. This allows us to do appropriate tabulation. And so when I run that through and take a look at the result, I get a value here that in turn is representative of the population. So in Mississippi, in the 2015 to 2019 ACS, we had males age 0 up to 1, 18,232. We can take a look at the end of the data set if we want to. It looks like in the ACS here, basically, we're going all the way up to 94. And again, as a reminder here, you're not necessarily going to have 100% complete coverage at these kind of small granular levels. That's just something to be mindful of. But what I can do here now, you'll notice with this end column, let's print this out again. We've applied those person weights using the weight argument here. And so what you're seeing is that these tabulations are not the number of rows in the data set. In fact, if we sum over that M column, we get a value that is Mississippi's population, just under 3 million people in the most recent 5-year ACS. We're drawing from this data set of 146,000 people, but again, this column here, our weight column, is used to make this representative of the US population. And it's interesting to think about this because, here in this specific Puma, we have someone who's age 53 with this particular education level, which I believe is high school, and sex of 2, so it's a woman. That person is only representative of 10 other people. But in other cases, this particular person here is representative of about 67 people. And so these records, they're not really to be thought of as individuals. They are individual records that are representative of the population more broadly. And so that's something that is really important to think about. With tidyverse tools, we can start to get a little bit more advanced. And credit to my collaborator, Matt Herman, I've borrowed from some of the examples that he has written up in the tidycensus documentation and adapted them here. We can use some tidyverse tools and use some appropriate weighting and summarization over the weights column to make some tabulations that are appropriate. Some of this code is a little bit more advanced. So if you don't quite understand it, we can walk through it. Feel free to use it for study purposes. But something that is really core to the tidyverse is this concept of group-wise data analysis, where you can, by group, tabulate data and tabulate observations in your data appropriately. And so in this particular case, we're doing a variety of things. We're taking our Mississippi PUMS data set, then we're creating a new column called BA above, which would be a logical column that's true if you have one of these codes that's representative of more than a graduate degree or more than a bachelor's degree or higher. We're then grouping the data set by Puma and by sex. So we're looking at educational attainment by sex. And then we're creating a number of summaries. The total population is going to be the sum over the person weight column. The mean age is going to be a weighted mean over the age column using the person weight. And then we calculate a couple columns, BA above, which is summing over the person weight, but only where BA above is equal to true and the age is greater than or equal to 25. And this is important to think about because under age 25, um, it's generally not considered to be appropriate, at least in census or ACS terms, to compare or think about educational attainment because it takes time for people to go through college and conceivably get advanced degrees. And so if you're saying, well, this particular area, nobody has a doctoral degree. And then if you actually look at the data and say, well, that's because it's a very, very young population that lives in this particular area, you may be making an incorrect inference. And so then we can calculate a percentage appropriately weighted as well. And when we go through and run that code and take a look at it, we can see what we get back. And now we have some appropriate tabulations. Total population, so Puma 100 in Mississippi has about 86,000 males, about 93,000 females. The mean age is interesting. The differences between the two, certainly for those of you from demography backgrounds, you know that women tend to outlive men. And we see that playing out in the mean age, maybe some outliers on the older end pulling that up. But the mean age of women in just about every Puma in Mississippi is about 2 years older or more than men. Then you can look at the number of men and women over age 25 and up that have a college degree or higher. And what's interesting about this is sometimes comparing the gender gap in educational attainment by Puma. In some cases, women are well ahead of men. In other cases, it's less so. And so that's the kind of interesting analysis that you can do when you're tabulating this sort of information. But again, remembering that you need to use those person weights appropriately, because if you're not using them with the microdata, you're going to get incorrect inferences back. And that's why we return those weights by default every single time. Tidycensus, just as the general design philosophy of tidycensus, certainly the application areas for data analysis are quite broad. And I certainly don't know every single way that people are going to use census data. And you could always go directly to the API and pull down any data you want. But Matt and I have been fairly opinionated on, at the very least, what things are important to provide to data users, to try to not make decisions for them, but try to kind of push them in the right direction and help them make informed kind of analytic choices. One is always returning the margin of error when get ACS is called for aggregate census data or aggregate ACS data. I've had some requests from people saying, can I avoid getting the margin of error back? I don't want it. And I say, no, you can't. That's you'll need to go elsewhere to get your data if you don't want the margin of error. tidycensus will always give it because it considers the margin of error to be a first class, a first class member of that data set. It's the same deal with get pums. You can't consider this information independent of the weights because it's a weighted sample. And so keep that in mind when you're doing your analysis. So what can we do with this information beyond data tabulations? We can look at some advanced examples. One is geographic patterns. This is something that's pretty interesting. I mean, Mississippi has some of the lowest levels of educational attainment in the entire country. But at the same time, you will notice substantial geographic variations that play out. And you can even get a sense of that when you're looking at this data. You've got some Pumas here. We have 27.8% of women age 25 and up have a college degree in this Puma, but if you look at men in Puma 300, it's only 12.4%. So there's some substantial differences. Maybe we want to see if there are any geographic patterns at play. And so you'll recall from the previous section that we can grab Puma geographies from the Tigers package using the Pumas function. And so if I say Pumas for Mississippi, for those of you who didn't attend the second workshop, the CB equals true argument gives you generalized data that are faster to download and clipped to the shoreline of the US. So they're a little bit more realistic looking when you map them. And I'm going to use some tidyverse functions to put this together in this more advanced example. I'm going to use the tmap package for mapping. And so I pull down the data, and then I take my Mississippi Pumas geographic data set. Then I perform a left join where I'm joining my summary data to it, where I'm matching the appropriate columns in the data set. So the Puma value in the data set we obtained from Tigris is called Puma CE10. We match that to the Puma column in our tabulated microdata set. And then I'm filtering where sex label is equal to female. So I'm just getting back the rows per Puma for women. And so let's go ahead and run that through. All right, so I've run that data through. If I take a look at my joined Pumas data set, this will be familiar to those of you who attended last week, but what we have for those of you who are less familiar is a simple features object. This is the modern implementation of vector geographic data in R, which means discrete shapes. So each row in this particular case is representing a Puma, and then we have data that's attached to it. And indeed, we even see this name column. If I pull this over, you'll see that looks like Puma 800 is the South Delta region. Puma 1600, that's the Southwest region. And we can start to do some mapping of that. So we're going to use, in this particular case, the tmap package to do some mapping. And so the tmap package, I'm not going to go into this in great detail right now, though in hour 2 of the previous workshop, for those of you who didn't make it to the last one, if you check out the recording there, we do a deep dive into tmap. It's really a wonderful package for thematic cartography in R. And I've only scratched the surface really of what it can do in these demos, but it's really great for quick geographic visualization and also more advanced cartography. And so what I'm doing here is I'm grabbing my Pumas. I'm saying that I'm going to map it as polygons, where I'm mapping the percentage, in this case, of women with a college degree. I'm going to use the greens palette, so light green to dark green, and then I'll put the legend outside the map. And so running this information through, let's pull this map up. I've got myself a map of Mississippi that's showing the percentage of women with a college degree. And you'll notice here, in some cases, in eastern Mississippi, it's low, fairly low through the Delta region. And we have here, this is the area around Jackson, Mississippi, but the northern suburbs of Jackson, the Puma that covers the northern suburbs of Jackson, that is the richest Puma in Mississippi, and it also has the highest level of educational attainment, so falling into this 40 to 45 bucket for women. So we do see some noticeable inequities. You have relatively low educational attainment. I believe this particular area, it's Madison County, Mississippi, is the only area in Mississippi that is above average income-wise for the United States. So we see that play out with respect to relatively high levels of educational attainment in those northern Jackson suburbs. So if you want to do some mapping of PUMS data, you'll notice here that Mississippi has a couple dozen Pumas in it, and you can actually start to do a little bit of geographic analysis here. It's not always perfect. The shapes aren't always exactly going to be what you like. Again, when you look at Puma geographies, and I saw one question in the chat about this, what is a Puma? It's, and JP answered it quite well. Basically, it can sometimes be a collection of counties. It can sometimes be subsections of counties that are designed to try to align with coherent parts of cities. But it's not always exactly consistent across places, especially when it's trying to, say, align with community districts in New York, as opposed to other places. But by and large, census tries pretty hard with respect to Pumas to incorporate local input and make it geographically coherent. So you can really think about combining areas that are fairly similar so that you can really distinguish across places. And we get a little bit of a sense of that here. So the area around Jackson, we have a little bit higher educational attainment than the rest of the state. All right, so moving along with some more advanced examples, we've looked here at how to tabulate data appropriately and then how to map data. Saw a couple interesting questions about variance estimation and tabulation of errors and replicate weights. So this is a more advanced example, but tidycensus, what Matt and I have done, huge credit to Matt on this one, is put in some functionality to try to streamline this process and make it ideally easier for users to grab this information and do appropriate variance and standard error estimation when performing analysis. So with respect to the ACS, broken record a little bit at this stage, but the ACS is a sample and it's in turn subject to sampling error. This is essential to understand. The number that you're looking at is not a specific exact count of the data. It's not. It's an estimate that is characterized by error. And when we're tabulating PUMS estimates like we've been doing, everything that we look at is indeed a point estimate, but we're not seeing the error around that. And so in some cases, you might be interested in tabulating that error yourselves. And we include some tools to assist with these tasks and take into account the complex sample design of the ACS, which is essential to incorporate into your data analytics work and also any statistical modeling that you do. So for those of you who might be coming from, say, a SAS background, I originally started modeling PUMS data in Stata. So some of you may be coming from a Stata background and have maybe worked with some of the survey modeling tools. R has a very robust and well-established survey data analytics infrastructure that can account very readily for survey weights and handle them appropriately in your analysis and modeling. The survey package is the gold standard for working with survey data in R. It's been heavily used, heavily verified, and works really, really well. More recently, Greg Friedman Ellis, formerly of the Minnesota Population Center, where he first wrote these tools, he was the original author of the IPUMS R package too, wrote the surveyor package, which adapts survey syntax to dplyr tidyverse style syntax. So you can use tidyverse functions to work appropriately with survey design objects, which is really, really cool. And we include functionality in tidycensus to plug into these packages and help out analysts as best as possible. So I saw one question about replicate weights. Replicate weights are commonly used for estimation of standard errors around some of these point estimates that we're tabulating. They're not necessarily the easiest things to get or work with because what Census publishes are 80 replicate weights to kind of get a sense of an error distribution around a particular point estimate and generate standard errors. And so those replicate weights are other weights that could conceivably be true for each household or for each person. And manually, you would need to go in and specify and download each of those replicate weights yourselves. But we include an argument rep_weights in get PUMS, and you can choose person weights or household weights if you want, that will go in and actually pull down that data directly. So this is pretty handy. What I'm going to do actually is I'm going to start pulling that data down. This takes a little time to do. So I'm going to go ahead and pull that data down. If it ends up taking too long, I've got the object saved out for purposes of illustration. A couple of things. This takes time. What we're doing under the hood here is pulling down data from the 5-year American Community Survey from Mississippi for those variables that we want, but also 80 replicate weights. So PWGTP1, PWGTP2, 3, 4, 5, all the way through 80. And so we're automating this process under the hood so you don't have to do it. All you need to do is say rep_weights equals person, and we pull down all that data for you. What that means is it takes a little bit of time to download. So on a slow internet connection, that's something that's going to be a consideration. If you're in the RStudio Cloud environment, I wouldn't recommend trying it. You might run out of memory because you're having to pull down quite a bit of data. So that's just a heads up. So when we're working with replicate weighting, we can pull down all of these 80 replicate weights directly. And so when we take a look at what we get back, and this will print out in my R console when it's ready to go, you'll notice that we have our data, but we have 92 columns in this particular case, where we have our normal person weight, but we also have, and it even prints out so much, it goes off the end of the screen. We have all of those different replicate weights. And so we'll show you some tools. I'll show you some tools in just a little bit for how to handle that. So Census publishes formulas that you can code directly yourselves for how to generate standard errors around estimates using the replicate weights. But you can also use the survey infrastructure in R to do this sort of thing directly. And so it looks like we pulled down our data. We got it all here in R, and we can take a look at what that looks like. So one of the features, the new features of tidycensus that I'm particularly excited about is the function that we wrote called toSurvey. And the toSurvey function automatically converts your microdata object to an object of class survey or surveyor to be used with those packages. And what that does is it inspects the data set and takes a look at the survey design and then creates a survey design that's appropriate. So if you wanted to use a replicate weight survey design, you specify, okay, I want to do person weights, type equals person, and design equals rep weights. You can also do a cluster survey design, which I'll show you in a little bit. And so what this does is, without having to pull down all that data and specify kind of specific details, it converts that over to a survey object for you. And one of the great things about a survey object is that when you perform calculations on that survey object, it will handle that complex survey design appropriately and estimate standard errors for you. So I want to show you how that works. We learned the count function in dplyr before, which was tabulating information, for example, potentially by sex and age. Let's say we want to look at sex by Puma. If we use the survey count function, you'll notice that we get back not just a point estimate, but we get a standard error as well. And you get that automatically because we're using that function over our survey object. So we're going to use the toSurvey function. We're going to convert to a survey object. And so you'll notice that it's a replicate weight design here. And then we can run this code, survey count, and it tabulates our data appropriately, but it also gives us standard errors based on the replicate weight design, which again, for me, is one of the most exciting new features of tidycensus in the past year. We can even go back to our more complicated example and generate standard errors around all of those estimates. So what we're going to use is survey total here to summarize our data, and then survey mean to generate a standard error around our bachelor's degree above proportion. And so we can get a confidence interval as well. If we do var type equals CI, we're getting a standard error in this particular case. So if I go ahead and run this information through, it'll take just a few moments to compute. I use the glimpse function to take a look, and you'll notice that for each of those point estimates that I've tabulated, I get a standard error attached to it. This is really, really handy. The surveyor package, the survey package and the surveyor package are fantastic for making what is sometimes a fairly complicated task to wrap your mind around, dealing with survey data and survey weights. it makes that process more straightforward and allows you to use syntax that you're familiar with. From there, we can start to think about converting standard errors to margins of error. Census provides some simple formulas to do that. If you want your familiar 90% confidence level, multiply your standard errors by 1.645. You'll multiply it by a little bit more if you want 95 or 99% confidence level, but that will give you something fairly equivalent to margins of error that you'll get by default in the ACS. And for those of you who attended the first workshop, or again, this is a core example in the tidycensus documentation, you can create a margin of error plot. And so let's go ahead and run that code through. Where in this particular case, we're creating a new column here, which will be the margin of error by multiplying by the appropriate coefficient. We're going to focus here on where the sex label is female, and we can create a plot. One of those little TIE fighter margin of error plots by Puma. I'll make this a little bit bigger. And we're comparing here. We see that area north of Jackson where educational attainment is quite high, but we're also estimating that margin of error on the point estimate. And if you follow this process, for those of you who want to maybe push this to the next level a little bit and do some validation, take a look at how this compares with what you would get if you pulled this information down directly using Get ACS from the Aggregate American Community Survey. In many cases, it compares quite favorably. It's not always going to be exactly the same. And if you have access to aggregate data for a particular statistic from the ACS, that's going to be your best bet for getting the most accurate estimates and margins of error. But if you're doing more complex cross-tabulations and you want to get a sense of the error around those estimates, this is a great way to do it. All right, the last example that I wanted to illustrate in this second hour of the workshop covers modeling with PUMS data. And I saw a question in the Q&A about this. Basically, how does the package deal with subsetting and filtering with respect to survey samples? Because something that is also very important to understand, as it will very much impact standard error estimation for when you're modeling survey data, is that the sample design of a survey when performing modeling on it needs to be preserved. And what this means is if you are trying to say fit a model on PUMS data and you just take a subset of it and then you fit a model on it, you've thrown out a lot of information that is important to understanding the sampling design of the survey. And that's going to impact those standard errors and could ultimately, give you some incorrect estimates. And so you can do modeling using the survey package on survey objects that handles this appropriately over subsets of your data. And I want to show you a brief example of how that works. So this is again adapted from the tidycensus documentation, thanks to Matt Herman's great example, where we ask a question here: what's the relationship between wages and the class of a worker and commute times in Rhode Island? So we're trying here to fit a model that predicts the commute time of a commuter based on their wages and the class of worker, which basically means what sector do they work in, or do they work from home, that sort of thing. And we'll take a look at Rhode Island here because it's a relatively smaller example to look at. So let's go back to R and we'll go ahead and pull down that data. Doesn't take too long because Rhode Island is one of the smaller states. So when that data is pulled down, let's go ahead and take a look at the slides again. We want to think about how we model this data appropriately. You can't just throw your basic LM linear model function at the PUMS data without accounting for the sample design and without accounting for the weights. And fortunately, the survey and surveyor package can handle both of those things. So PUMS data have a complex sample design. I've mentioned this before. And modeling for correct variance estimation with PUMS data require accounting for that. So we have observations that are clustered both within primary sampling units, which are households, and also within what are called strata. And the strata in the ACS microdata will be the PUMA. And so you have, again, clustering within the PUMA, and then you have also the household level sampling. And this design needs to be accounted for appropriate variance estimation. And so to do this, when you don't have replicate weights, you can specify using the toSurvey function design equals cluster. And by default, what that'll do, given the internal structure of how we return data in get PUMS, it'll account for both the primary sampling unit, so the cluster, and it'll account for the PUMA as the strata. For those of you who have modeled PUMS data before, you're probably familiar, or survey data more broadly, if you're trying to analyze subpopulations, the subpop command in Stata comes to mind, or the subset command in the survey package comes to mind. In the surveyor package, the filter command will do filtering appropriately. Instead of jettisoning observations, the appropriate way to handle subsetting in survey samples is to set the weights of unused observations to 0, but keep those observations in the data set so you get a sense of the broader structure. And that's why the surveyor package is so cool. You can use the filter command if you have surveyor loaded, just like you would in dplyr, but it's going to do filtering in that appropriate way using familiar syntax. So what we're doing here is we're fitting a model for only civilian employed people. In this particular case, doesn't work at home, earned wages last year, and the commute is more than 0 minutes. So we're going to fit a model in a subpopulation, but we're filtering here the survey object, and in turn, that'll help us do the estimation appropriately. Finally, we can use a modeling function in the survey package here. We're going to use survey GLM to do that. We're going to estimate the journey to work based on wages and employment type. And we'll use PUMA as a dummy indicator here. And then we can see what we get. All right, we fit the model. And we have fit the model appropriately to the survey data. And we can inspect some of the results. So it looks like wages are positively associated with commute time. So if you make more money, you're probably commuting a little bit longer. If you're self-employed, or if you're working in the public sector as opposed to the private sector, your commute times are a little bit less. That makes sense. If you're self-employed, you maybe have more of a choice to live near to maybe the shop that you own. And then we can do some comparisons across PUMAs as well relative to the reference group, which is, I believe, PUMA 101. So this is just kind of a basic modeling example. It can get more complex than this, but for those of you who are interested in modeling with PUMS data, what we've tried to do with some of these tools in tidycensus is help you integrate and interface with the survey modeling infrastructure in R as best as we can, and make sure that you're making good decisions with respect to handling those survey weights, which admittedly is something I've spent many hours reading documentation on in graduate school and beyond. It is not a simple topic. If some of this seems more complicated, I totally get it. But hopefully this can kind of help you use some of these tools. If you're coming from a Stata workflow, for example, or a SAS workflow, some of the concepts might be familiar, and you're coming over to R. Hopefully this can assist with that a little bit. All right, so that's it for part 2. I've got a few exercises that we can do. So let's break for 10 minutes. So maybe break until 4:05, and then we'll kick off the third hour. So a few suggestions here, a more basic example and then a more advanced example. So using the data set you acquired from the exercise in part 1, or if you didn't do those exercises, just use the example Wyoming data set, tabulate a group-wise summary using the person weight column and dplyr functions. If you want to get more advanced, use get ACS using tidycensus, look up the appropriate variable using load variables in tidycensus. Again, this requires an understanding of tidycensus, and then try to match your tabulated estimate with what tidycensus gives back and see if it's the same or how off they are. And the second advanced follow-up would be to try to use the replicate weights and calculate the margin of error in the way that we learned using conversion to a survey object, and then calculating those standard errors and then the margin of error. So those are a couple more advanced examples. You might not have time to do that in 10 minutes, which I totally get. So try this out after the workshop if you want. At the very least, if you want to try out the exercise, try the first one, pull down some data, and then take a look at that person weight column. All right, so let's break until about 5 after the hour, and we'll have a little bit of time for Q&A, and then we'll go into our bonus section, which is covering non-US census data resources.
Okay, it is 4:05. We are going to get started. We want to leave as much time as possible for Kyle to walk us through all of the options for accessing international census data. So we're going to actually leave the Q&A session to just a single question for Kyle. And Kyle, when you're ready,
Yep.
We have some interest in maybe the future of tidycensus.
Sure.
Maybe there's some things that we aren't all aware of right now, but there are some questions about will tidycensus either now or in the future offer access to some of the other data sets that either the Census Bureau or other federal agencies make available. So the CPS, or current population survey, is one of the ones that I've seen a few
Sure.
questions about.
CPS is coming. I don't have a timeline for that, but we have some experimental work on it at this stage. That is a data set that's probably right at the top of my priority list for incorporating. One of the issues, and it is doable. One of the issues is that neither Matt nor I are sort of heavy CPS users, and so we want to make sure we get it right. We have familiar with the PUMs, and so it was sort of logical that that would kind of translate in with what we're trying to do. CPS is different in that, so you have the March supplement and you have the quarterly estimates, and and you have, and so how do we handle that? The weighting, we need to make sure we get that right, and so that's sort of a longer term goal, but it is coming in the future. Though no promises on a timeline on that one. And as far as other data sets are concerned outside the CPS, never say never. Again, we've got migration flows. That's in a relatively advanced stage. That's coming pretty soon. But there's a lot of data resources that Census provides, and tidycensus's goal has never been to give access to all of them. It wants to do a really good job in a particular way of giving a sort of pre-processed access to a select number of very popular data sets. Again, Hannah Recht, who is a very talented R developer and maintains the Census API package, who some of you may already use. If you don't, I encourage you to check it out. You can get ACS and census data from there too, because it's built to tap into every census API. And that's quite the feat. She sometimes has to play whack-a-mole a little bit when one of the APIs goes down, and then someone says, "Oh, why isn't this working?" It's not as big of an issue with tidycensus because there's only a few that we access. But that's a great place to look if you need access to some of the other data resources. There are also some data resources that are best served by other R packages that other developers have focused on. So one of my favorite data sets to work with is the loads data set, the origin destination kind of commuting data. Jamal Green, who's out of Portland State and the University of Pennsylvania, he has done a fantastic job with his colleagues on writing the leader package, spelled LEHDR, which is really, really great for getting data from the LHD and the loads data sets. But that's not something tidycensus would do. There's another data set that does the quarterly workforce indicators. I think it's called tidyQWI. There's another package called BLS Scraper, which I use to get data from the Bureau of Labor Statistics APIs. So there's a lot of resources out there, and tidycensus is not going to try to be a one-stop shop. But we'll probably continue to add features as we go. I tend to add them as I have a new research project. Something to keep in mind as well, tidycensus has been grant funded by the National Science Foundation the last few years. That grant is starting to run out. And so something that I am open to is sponsorship for the package. And so if somebody is interested in having new features implemented and is interested in coming in with some financial support, It is open source software. This is not something we sell. We provide it for free. And you know, we've had some I've had some grant support to support the package, but again, that's running out. So that's something to keep in mind as well. And you could, I'm always welcome to hear those inquiries. And you know, some of the new features of tidycensus have come out of consulting projects. So you know, that's something to keep in mind. You know, it definitely is. I enjoy very much seeing the community kind of use these resources. The number of research papers on COVID-19 analysis and mitigation that use tidycensus is growing and growing, which is wonderful. But you know, at the same time, any financial support is welcome if new features are desired. So keep that in mind.
Sorry, I was just going to say, well, if the participation in the webinars this month has been any indication, there is plenty of interest from a wide range of users. So, so hopefully someone will be in contact soon.
Yeah, that'd be excellent.
But as we move from the question that was asking about other domestic data resources, you know, I think there's a great amount of interest in this third hour looking at international data resources. And I think there are a number of people who were asking even earlier in today's session about international resources. So without holding you back any further, let's move on to international census data resources.
Yeah, let's dive in. So, you know, we've spent all of the time in these workshops to this point focusing on US Census data. And if you're interested in US Census data, that's great. If you're working in non-US contexts, that's maybe not as useful. And what I wanted to highlight in the time that we have left are a sampling of non-US census data resources in R. You know, tidycensus is US focused. It will remain US focused simply because the various census resources that are available around the world are fairly idiosyncratic and merit their own R packages to handle those idiosyncrasies. And so we're seeing an interesting ecosystem of R packages emerge that are designed to consume data resources. And it's a bit uneven. I mean, I've done some work looking at international census resources, and we're a little bit spoiled here in the United States with the Census Bureau's API, which is a phenomenal resource for developers to plug into. You know, in many cases, you know, governments will only make their data available in spreadsheet format. If that, sometimes it's PDF documents. I'm going to share an example from an R developer whose new package. What she did is she actually went through and scraped all the data off of PDF documents and made it accessible to us in R, which is amazing work to do. But sometimes that's what it takes to get these resources up and running. So I want to show you a few resources that are available. So we focused on the US to this point, but you know, certainly we're interested in non-US resources. And I want to show you a couple families of resources that are available. The US Census Bureau does maintain a database called the IDB, or the International Database, that includes not census data, but demographic data for countries around the world and population projections. And I'm going to show you how to use that in R. There are also country-specific census data packages from around the world. I'm only going to show you a sampling of them. There are a few of my favorites. And so hopefully you'll find them useful if you're working in those non-US contexts. There are a few more, and certainly would love to see an ecosystem continue to grow that makes international data open to our users. So the first example that I want to show is coming from the US Census Bureau's International Database, which is a really cool resource that was really one of my first forays working with the Census Bureau's APIs. I was using this more than I was actually using domestic data resources because I was teaching courses in world geography at TCU. And, you know, when you're teaching world geography, for those of you who've taken geography classes, there are multiple approaches that you can take. And some of my colleagues are astonishingly well traveled. Astonishingly, they've been everywhere. And so their classes are just, it's like going through photo albums, and they have all of these memories and specific experiences in places around the world that they can draw from. And I am not as well traveled as my colleagues. And so everybody at TC, we teach at some point our intro level world geography class, world regional geography. And so I didn't have that experience to draw from. And so I thought, well, what I do have is data analytics experience. And that's the lens through which I can try to teach these classes, making unique charts, using unique data in a sort of Hans Rosling Gapminder style to try to illuminate various, aspects of inequities and regional characteristics to students. And so that's the approach I took. And I started drawing heavily on a couple of different data resources. One was the World Bank's Open Data Catalog, which is available in an R package as well. And one is the International Database, which didn't have an R package at the time, but 5 years ago, I decided to write one. It is not as heavily used as Tigris and tidycensus. It's not been in active development, in part because the IDB API has not changed much. But the package is called idbr. It's published on CRAN, and it works. It's not as smooth as tidycensus, in part because the API is not structured in a scalable way like tidycensus is. Oftentimes, data are available one country at a time, and so under the hood, what I've had to do is build out infrastructure to iterate through and hit the API multiple times and then assemble a data set. And so it can be kind of slow, but it does work, and you can do some pretty interesting things with it. So there are a couple core functions implemented in idbr. One is idb1, which it's a bit of a misnomer, but it's the way the APIs are named. I might have named it something different if I were writing the package today. But they have two APIs, the 1 year age band API, which allows you to get population data by 1 year age band, and the 5 year API, which allows you to get age data by 5 year age band. The 5 year age band API also gives you a bunch of demographic indicators that you can get. So it's a little bit of a misnomer. Again, I probably would have changed that going back, but this package has been around for a while, and still there are people out there using it. And I use it from time to time as well to get data. And so I want to show you how it works. One thing that I'm looking to integrate in, and it's in the development version of idbr, it's not in the published version right now. So for those of you on our Studio Cloud, you would need to run this little bit of code, or you'd actually need to replace this bit of code using the IDB API key function and plug in your census API key. So the same census API key that you use for tidycensus works for idbr. They're just not fully integrated yet. I'm working to integrate them, and in the next release of this package, it will be integrated. But you will need to key with the IDB API key function, which again won't be an issue if you use tidycensus in future releases, but it is at the moment. And so the IDB5 function, just as an example here, it allows us to answer all sorts of interesting demographic questions. For example, how has life expectancy at birth changed in Southeast Asia over the past, 25 years or so? And so I can specify here a vector of countries. I'm going to look at Laos, Vietnam, Cambodia, and Thailand. I'll look at years from 1995 to 2021. I'll specify a variable, and then country name equals true. If you specify that, it returns an informative column with the country name instead of a country code. And so if we jump back over to R, this code, my apologies, it's not fast because it has to go through and hit the API a bunch of times, as I mentioned, and stitch everything together. And but it is functional. So we can take a look at our data here. Let's look at our Southeast Asia life expectancy. And we get here a data set that has a column E0, which is our life expectancy. we have the time, so that's the year column, and then we have the name. And so for these 4 countries in this long form data set, I'm able to make those comparisons over time. I've got an example here with ggplot where you can make a basic line chart to compare the life expectancy at birth trajectories of those 4 countries over time. I can run that through. And here I have such a plot. So I'm going to make that base size a little bit smaller because I'm not printing that out for display in slides. And you can see here that Thailand and Vietnam have higher life expectancies than Cambodia and Laos, but the trajectory is upward for all 4. And so you can do this type of comparison for any country in the world. And there is an internal data set called IDB variables that allows you to, if you call that internal function, it'll basically print out all of the different variables that are available. In fact, what I'm going to do, I'm going to print that out here, and you can see here what those different codes are and what they mean. Again, this is a package I wrote 5 years ago. It's not as smooth as tidycensus, but it is functional. And so if I want, say, infant mortality rate, I can specify IMR. If I want age-specific fertility rates, I can grab them. Crude birth, crude death rate. So there's a lot of kind of core demographic statistics that you can get. And you can get population projections all the way to 2100, which is pretty cool. So if you're interested in doing some comparative international analysis, idbr can help you out with that sort of thing. Additionally, you can make interesting comparisons. For example, let's say I'm interested in knowing what are the 10 countries with the highest total fertility rates in 2021. I can specify country equals all. That will give me every country in the world for which the IDB has data, which is most of them. This again is slow because it needs to query every country one at a time, but it does work. And I use here the slice max function from dplyr to give me back the top 10. And so these are the 10 countries with the highest total fertility rates in the world. Niger has long been the country with the highest TFR. And total fertility rate, for those of you who aren't demographers, is a synthetic measure that says basically number of children per woman given given current age-specific fertility rates in a year. So it's not the number of children per woman specifically, but it's sort of a synthetic comparative measure that allows you to kind of look at fertility rates based on population structure. So Angola comes in at number 2, Democratic Republic of Congo comes in at 3. And so those are a couple examples of how you can use IDBR. There are a lot of really fun things that you can do with it, though. So my friend and colleague Ari Lamstein, I wrote a blog post over at his blog a few years back, and one of the main reasons I wrote IDBR is to make international population pyramids. So in my teaching, I use these graphics all the time because I think they're so interesting. And in workshop 1, if you didn't attend, we actually learned how to make population pyramids for the United States. You can do that sort of thing in IDBR. This is a more complex example, and you can even use animation toolkits in R to create animated population pyramids. This is one of my favorites, looking at Nigeria and asking questions like, okay, what do you think is going to happen? What is happening with Nigeria's population? What is going to happen to mid-century? At which time Nigeria's population is expected to surpass the United States, become the world's 3rd largest. And so these are kind of interesting graphics that can be generated. If you visit Ari's blog, you'll see the code that was used to generate this plot. You can also use it to show population aging as well over time, say for European countries. That's a fun application area as well. So give idbr a try and file some issues as well. I would love to get some feedback, dust it off the package a little bit to illustrate or demonstrate this to you today. But feel free to give some feedback, file some issues, and let me know if there's anything else that might make it a little bit more useful. So that's idbr, population projections, demographic statistics for a variety of interesting indicators country-wise around the world. But what if you want to do tidy census style analytics for countries other than the United States? There are some options available for you around the world. The one a fantastic example is the Census package, developed by Jens von Bergman and Dmitry Shkolnik for Canada. And Census, for those of you who are tidycensus users, will feel familiar. The syntax is not the same because the censuses are not the same, but you can do a lot of very similar things. So Statistics Canada does not itself have an API, but what Jens has done is stood up his own API called Census Mapper, and Census queries that API. And it works really, really well. So I mentioned at the beginning of the workshop, if you want to run these examples, you'll need to go sign up for a Census Mapper account. You can just visit the website, sign up for an account, and it'll get you an API key. You can then use that API key to run these examples. So this won't be directly reproducible for some of you, but if you want to come back to it at a later date, once you've acquired that API key, you're welcome to do that. And just follow along with the examples and see the types of things that you can do. So what I'm going to do here is I'm going to go ahead and read in my Census API key and load in Census. And analogous to the load variables function in tidycensus is this list census vectors command. And so CA16, that's from the 2016 Canadian census. If I run that code, I get this data set where I can go through and see all of the variables, which are called vectors in the Census context, that you can get. And there is a ton. There's thousands of indicators that you can look at with all sorts of interesting information. So you've got age. We can go down. We've got language, which I'll show an example of in a little bit. We can keep going. We've got place of birth. So if you want to study immigration, we've got information on Aboriginal status, so First Nations peoples in Canada. Lots of interesting demographic analysis that could be done at very granular geographies. So geographies, say, analogous to US Census tracts, which allows for really interesting analytics and mapping. And so to show you how this works, I'm drawing from an example, again, that I've used in my teaching. One thing I focus on in an urban studies class that I teach regularly at TCU is we look at cultural geographies of Canadian cities. And so one really interesting example to look at is bilingualism in Canada and different geographies of languages. And so I use Census to pull this data. And so just showing you a basic call, your core function in Census is going to be called get census here. And so I'll go back to the slides so it's a little bit bigger. And you can specify arguments that are analogous and should be kind of familiar if you've used tidycensus before. They just have different terms that refer to them. So data set, that's going to be the census that you're pulling from. In this case, we're grabbing from the 2016 Canadian census. The regions, we can specify a list of regions here. I'm pulling here. This is a region code for Montreal, the Montreal area. The vector I grab, this is the number of English speakers in a census tract. And so that's the vector code that I grabbed from that data set that I just showed you. The level here, I'm specifying as CT. So there are a variety of levels. You can review the Census documentation for all of them. What's great about Census, and one thing I really love about it, is you can get back simple feature geometry, just like in tidycensus. If you specify geoformat equals SF, you get back a mappable data object. And so let's go ahead and run this code through. We query the API, and let's take a peek at our data. So I have a simple feature collection. And I've got a bunch of information that comes in by default, which is something I really, really like. So you actually get by default population and households and dwellings. I didn't ask for that information, but I get it by default. I get area, and then I get my the vector that I requested. So all of these rows are census tracts in the Montreal area in Canada. And then this particular variable, that gives me the number of people whose primary language spoken at home is English. And so what I can do is I can start mapping that information directly because I have a simple features object uh, ready to go. And so using some of the tools that we've covered in this workshop series, like tmap or even ggplot2, I can start looking at the geographic distribution of English speakers in Montreal. And so moving through here, let's do a couple things. I'm going to do a little bit of data wrangling to prepare my data. Given that I have a population column, I'm going to normalize and make a new column called % English. Again, the way to read this is I take my Montreal English data set, then I use the mutate command to create a new column called % English, which is 100 times number of English speakers divided by the total population. I'm going to use my tmap syntax where for that data set, I'm going to map polygons where the color is going to be % English. I'm going to use the Veritas color palette. I'm going to set a transparency of 0.5. And I've got some other information there. One interesting thing about tmap that is pretty great for data exploration is you can get static plots or interactive plots. The default tmap mode is plot. That gives you a static map. But if you specify tmap_mode view, that gives you an interactive browsable map. And so running this code through, what I have here is an interactive browsable map. I'm going to change to the OpenStreetMap base map where I can go and actually explore the % of the population that speaks English at home by census tract in Montreal. And what you can see, there are very distinctive variations. You have here in the southwestern portion of the city, locations are predominantly English speaking. Those bright yellow areas are areas where over half of the population primarily speaks English at home. But in northeastern Montreal, and then especially out in the suburbs, those are predominantly French-speaking areas. And you'll have a few areas. Montreal is a very diverse city where all sorts of international languages are spoken. But Census, with just a little bit of code, allows you to tap into these data resources and do the same kinds of interesting census analyses in Canada that we can do with tidycensus and these R analytic tools in the United States. So Census, it's one of my all-time favorite packages. Whenever I need information for Canada, it is the first place I go. So to show a few other packages to take a look at, there's an example map in the slides. We can grab data as well from Mexico. And unlike most countries, Mexico has an API. Its statistics agency is INEGI, and they have an API that you can plug into. And there is an R package called INEGI-R that allows you to pull down data from that API. The MX Maps package is a package that wraps INEGI-R and also includes some data of its own that allows you to make some interesting maps. You'll need an API token to get this to work. It took me a couple tries to get it. I had an old one, but I couldn't find it, so I pulled a new one down this past week. Took me a couple tries to get it, so be patient if you don't get it right away. But once you have it, it allows you to do some interesting analytics. So taking a look at how this works, just to show a couple brief examples. MX Maps is not available on CRAN, so you can't get it with install.packages. You'll need to install it from GitHub using the command that I provide on the screen there. I'm going to pull in my inegi token and assign it to a variable called token inegi. And this package, the MX Maps package, is inspired by Ari Lamstein's package Choroplether, which wraps the ACSR package to rapidly make visualizations and maps of US Census and American Community Survey data. So the syntax will be a little bit different from what you're familiar with, but just to walk you through this, in MX Maps, the Choroplether function uses the inegi-r package under the hood to query the Mexican data resources API. And it grabs data for, in this case, all the states in Mexico. This indicator is one I found very, very interesting. It's the percentage of the population that is Mexican born, but born outside their current state of residence. And so it's thinking about percentage internal migrants. And it has to be people that have moved within the past 5 years. So recent internal migrants, recent internal migrants. And so I found this to be a really interesting map. I'm going to go ahead and run this through. It's going to pull down data from the inegi API. Takes a few moments to do because the way it's structured, you can only pull one state at a time. And so under the hood, MX Maps is assembling this information for you and makes this interesting state level map. And so you see a few states, Quintana Roo, Nuevo León, Baja California Sur, those are the ones that have the greatest proportion of internal migrants. And that makes sense because you have two of the places that really have heavy kind of thriving tourist infrastructures. So you have a lot of internal migrants going there. Nuevo León, one of the richer states in Mexico, you have a greater proportion of internal migrants moving there. So, and then kind of some of the areas around central Mexico, Mexico City. And so some interesting patterns that we can, take a look at and analyze with respect to this variable. You can pull down the same information using inegi-r here. What this is doing is it's pulling the same information down. It takes a few tries to kind of figure out the indicator codes that are available and the data sets that it's available from. But if you're looking for Mexican census data, this is a pretty interesting resource that you might consider checking out. This code that you see here, by the way, just in case any questions arise, what exactly is going on here? This is a little bit more advanced code that uses tidyverse functions to iterate through all of the states in Mexico. And this sort of stand-in variable .x, what this is basically doing is it's saying for every state in Mexico, pull in data on internal migration for that state, and then assemble that all into an output data set that allows us to do some comparative analysis. So it's a little bit more advanced what you have to do to pull in some of that information, but it's a really interesting data resource. And again, most countries don't have a data API stood up that you can tap into. And so Mexico having that resource is pretty great. All right, so showing a couple other examples, one of the most exciting places for new R package development is IPA in Brazil, which thinking about some of the work that they're doing, really, really exciting stuff highlighted by the GOBR R package, and which is sort of analogous to Tigris, but for Brazil. And so if you're working with Brazilian data, what they do at IPA is they're hosting a bunch of Brazilian data sets, including census geographies, and you can, in a single function call, for example, here, read census tract, you can pull down data from their website ready to go as an R object for analysis. So there are regions, you can get physical features, you can get basically even census tracts here for state information. It's pretty great. And this doesn't include demographic data in this package, but Brazil has a pretty robust census data infrastructure. I've worked with their data before. It's quite nicely formatted, and it can be merged in using tidyverse tools to do some mapping. So really, really exciting development coming out of IPEA. Definitely a place to keep an eye on. And in basic terms, what you can do is fire up the package. I'm going to pull down here census tracts for Rio de Janeiro, the state of Rio de Janeiro. We pull that down. It's one of the more populous states, so it's going to take a few moments to pull that down. But once it does, what we'll be able to do, and so I'm going to let this download, is we're going to be able to make an interactive map using MapView, for example, that looks like this, or potentially do some analytics. This particular data set is generalized and simplified. So if you're doing spatial analysis, it's not recommended. There is an argument, I believe it's simplified equals false, that gives you a larger data set size-wise that hasn't been simplified, but is topologically correct, which means all the boundaries are good to go. And so we pull down this data. We can use our map view function to interactively browse it. Takes just a few moments because we have a lot of census tracts that we're working with. But now I can go in here and I can take a look at all of these different tracts across the state of Rio de Janeiro in Brazil. So what I mentioned before in terms of, say, thematic mapping, data in GeoBR versus spatial analysis, let's zoom in here to the Ipanema area. You can see that what these census tracts are called are not topologically kind of aligned or consistent. It means they overlap each other. That's because what the team has done is they've simplified this data to try to make it speedier to download. And so this is the data that you would want to use if you're, say, making a demographic map that's showing the entire state. But if we were, for example, to call, let's say, read census tract, and you can see the arguments here with simplified equals false, it'll take longer to download, but everything is going to be connected in the way you'd expect. And so if you're doing spatial analysis, that's what you want to make sure that you're doing. They just provide those different data resources for you. So keep an eye on this package. They're always updating it, and they're coming up with a lot of really interesting tools for routing and transportation, and just doing some fascinating research on accessibility out of this shop. So it's definitely a place to keep an eye on with some pretty innovative research. One of my favorite recent packages for census data that came out within the past year is the R Kenya Census package by Shel Kariuki. She's an analyst working out of Kenya. And I mentioned before, we're very fortunate for those of us who work on US data to have the US Census Bureau's API. Some countries, for example, like Kenya, don't distribute your data necessarily in that way. And in turn, to get data out, you might have to browse through PDFs, and in some cases scrape the data from a PDF. And that's what Shel has done to make that accessible to our users. It was a phenomenal effort to do that and make the 2019 Kenya Population and Housing Census available. It's a really cool package, generally a data package that gives you access to the various tables that install directly with the package. So you're not having to query it or pull it down from a website. You install the package using the code here. It's hosted on GitHub, so you'll need to install GitHub to get it. But when you fire up the package, our Kenya Census, there are all sorts of different tables that are available. And so I'm going to type this in here real quick just to show you. We've got a data catalog and then lots of different data sets. And if I hover over the different ones, I can see what I get: rural population, population by sex, population by age and sex. And then we have, percentage distribution of conventional households by main mode of solid waste disposal. So kind of public health indicators, agricultural indicators. There's just tons and tons of data. And so if you're analyzing data for Kenya, and it can go all the way down to the county or even the sub-county level, this is a wonderful data resource. And included in the package is functionality to use that data. You can integrate it with the tidyverse to do some visualization. So I want to show you this first example. Religion is something that in the US Census is not collected, but in the Kenyan Census it is. You can pull down this data set on religious affiliation, and then create a proportion. In this case, let's look at the proportion by county that listed Islam as a religion, and make an interesting plot. So I'm going to go ahead and run this code. And let's make this a little bit taller so we can see it. In fact, I'm going to make the base size a little bit smaller for display on my screen. So let's run this through again. What we have here is a really interesting chart that shows percent Muslim by county in Kenya. In Kenya, as you can see, on the east side of the country, and especially those counties that are bordering Somalia or near Somalia, you have counties that are nearly 100% Muslim. But over on the west side of the country, that percentage is very, very low. Nairobi, the largest city, has, for an area over in the western part of the country, a little bit higher proportion that's expected. But this is the type of data that the package makes available at your fingertips and allows you to do this sort of analysis. And the last piece that's great about this package, kind of like the CAN census package does as well, is the package includes a geographic data set for counties in Kenya, which facilitates mapping. So what this code does here is we convert over to an SF object. We do a little bit of data wrangling to align our tables. But that's all we need to do to get started with some mapping. And so using the code that we have here, we can make a map of percent Muslim by county in Kenya. So let's go ahead and run that through. And here we have the map, and you can see some of those interesting spatial patterns where you really see this east-west divide that plays out. Again, those counties that are bordering Somalia, heavily Muslim, but you go over to the counties that are bordering, say, Tanzania or Uganda, very, very low percentages. And so TMAP allows for rapid mapping and customizable mapping. And if you're looking to explore these topics and geographic variations or divides within Kenya, this sort of workflow allows you to do it for any of these indicators. So this is a really fun package to work with. And if you're doing Kenya-specific applications, it's a great place to look. So those are a few of my favorite packages for non-US census data to work with. There are more. The NOMIS R package connects to the NOMIS API in the UK to allow you to pull down UK data. There's a really interesting Africa-wide project going on right now called AfriMapR, which it looks to kind of consolidate data resources across Africa and make them accessible in various R packages. So that's definitely a data resource to keep your eye on. Beyond that, if you're looking for microdata, because that was the focus of today's conversation, IPUMS International is an astonishing project that I learned a lot about when I was in grad school at Minnesota, but their team has been traveling the world talking to local census agencies and really unlocking census data and making microdata accessible for now over 100 countries. And so you can download that data from the IPUMS website, use it with the IPUMS R package, and do interesting microdata type analyses similar to what we learned today, but for various countries around the world. So that's definitely something to check out. All right, that takes us about to the end of the workshop period. In terms of exercises, because of the API key authentication, this might not be necessarily plug and play for everybody right at this stage, but I would say try picking a country from the examples above and explore a little bit further. The CAN census and the Arcania census packages are probably going to be the two demographically that you'll be able to get up and running with the smoothest. So try browsing the available variables, make a map, make a chart, try reproducing what I've shown, but for something different, and see what you can do for some non-US Census data examples. And you know, if you make something interesting, post it to social media and let the developers know. I'm sure they would love to see that people are using their packages as well. So that takes us to the end of the workshop series. So I want to thank Bill, JP, University of Michigan for hosting. I had a great time going through these examples, getting the opportunity to share some of the work that I've been doing with all of you. And I appreciated some of the feedback that I've been getting. So if you've made something interesting, if you learned something new, shoot me an email, let me know. Would love to see it. And thanks to all of you who have been coming out. So this is certainly for those of you who made, if there are any of you who were able to sit through all three of the workshops, that's an amazing feat, but I very much appreciate it. For those of you who maybe were just able to make it to a fraction, still very much appreciated that you came out and spent some time learning about these resources. So thank you.
Kyle, I just want to say thank you so much for another informative webinar. Today's session has been a great final chapter in kind of our March analyzing census data in our trilogy. And I just want to also echo what you said. From all of us at SSN and the University of Michigan, I want to thank all the participants who joined us today and for all the webinars earlier this month. But before we go, I do want to remind everyone that we will post the recording of today's session in the coming days. We'll send all of the registrants an email with the location of the recording. But if you saved the email we sent earlier today, you can go to the resources page that we linked to, and you'll be able to find both links to Kyle's code and his slides, as well as the recordings once we post them. With that, thank you again, everyone, and thank you for a great presentation, Kyle.
Thanks so much, JP. Really appreciate it. So, yeah, again, thanks to everybody for coming out.
Thanks, everyone. Take care.
All right, you too.